Hello, everyone. Good afternoon, and welcome to the NYIT webinar titled Data Mining, Becoming a Key Player in Data-Driven Future. I am Babak Beheshti, the Interim Dean of College of Engineering and Computing Sciences here at NYIT, and I am joined here by a few of my colleagues, Dr. Paolo Gasti, Dr. Helen Gu, Dr. Frank Lee, and Dr. Hui Cao. These colleagues are faculty members in the Department of Computer Science and active faculty members in the new data science program that we're going to talk about today. In the interest of time, to make sure that we have all of the content covered in the 45-minute period we have allocated to this webinar, we will get started. So let's go to the agenda. So what we are hoping to cover in this 45-minute period, which obviously I pretty much have used up my time already, is to give very quick introductory remarks. And then, as you will see, there will be some general overview of the data science by Dr. Gasti, some applications that some of our faculty are doing research on actively, and a discussion of what the curriculum of the data science master's program looks like. And we will have a brief period at the end for question and answer. All right, so I will make this very quick, just in the interest of time. Some facts about NYIT. We have been continuously rated as one of the top engineering schools in our category in the United States. The College of Engineering is a sizable one with 1,300 undergraduate students and 500 graduate students in our two New York-based campuses in New York City and on Long Island. As you see in this slide also, that our curriculum is complemented by a cutting-edge research that is done by the faculty members, and you will just get a very brief glimpse of it in this webinar, as well as a very engaged student body and a very active student body in terms of professional and volunteer activities. And just so that you have a sense of the size and the scope of the College of Engineering, we have about 53 full-time faculty in our two New York campuses, and we offer a number of master's programs and a number of bachelor's programs, and we are very proud that our master's in data science program, data science was approved by the New York State Education Department, and its inaugural semester will be starting this January spring semester 2019. We are focusing on three types of students for this program. Professionals that are coming back to school to either retool themselves or hone their skills in data science, as you know, has become a very, very critical item for many corporations and enterprises. Traditional students that want to just continue the bachelor's program to an advanced degree, and of course, students that are doing a change in their career paths in terms of their education focus is concerned. And again, very quickly, you would not be on this webinar if you were not convinced of what this slide is conveying to you. You know that data is the new oil. So data has become the focal point of almost all enterprises worldwide, because they can now tailor and customize their sales, their operations, and all of their activities to the specific needs of their customers based on the data that they can analyze. So with that, I'm going to pass it on to my colleague, Dr. Paolo Gasti, Associate Professor in the Department of Computer Science, to give you a brief overview of data science. Dr. Gasti?
Yes, hi everybody. Thank you, Dr. Beheshti. So I'll try to be brief here just to introduce the main main skills and main ideas behind this field. So let me start with big data. So the idea of big data, the term big data typically refers to all these applications that involve a large amount of data and therefore have unique challenges in terms of scalability, for instance, in managing this data. Now, managing this data is necessary because knowledge and data are not the same thing. There's a big distinction between the two, and just large amounts of raw data are not directly knowledge. Let me give you an example maybe to clarify that. So consider Netflix. Netflix has, give or take, 130 million users worldwide, and users combined watch something like 1 billion hours of videos, movies, shows every week. So we're talking about 50 billion hours per year, so in that range. Now, if I were to give you just this raw data with the challenge of increasing user engagement, recommending the right movies to watch next, well, that data alone wouldn't really tell you much. You would need a way to extract knowledge directly from this data and have insights that can help this company's business. Now, a data scientist is a practitioner who understands the domain and has sufficient domain knowledge. But not only that, has analytical skill, understand business needs, and has computer science expertise to do exactly that, to take the raw data and translate it into actionable knowledge. So next slide, please. Can we move to the next slide?
Yep, we're trying.
Oh, sorry.
There we go. Sorry.
Thank you. So data science is a multidisciplinary topic, and it's a well-rounded data scientist must be able to do several things, must be able to quickly relate to the problem that is trying to address, and understand and determine which information is needed to actually solve that problem. The data scientist must be able to apply his or her knowledge to that particular problem, and ultimately must be able to clearly explain his or her results to non-expert, to executive in a company, because these results have to translate to actionable information. And what this means is that a data scientist must have a deep understanding of AI, artificial intelligence, machine learning, statistics, data mining, database processing, data visualization, many, as you can see, many different areas of mathematics, statistics, and computer science. If we can go to the next one. And so to summarize, data science really requires well-rounded professionals that have significant expertise in various areas of computer science, domain knowledge in the particular application that they're going to work on, and mathematics and statistics. Now, while we were designing this program here at NYIT, we reached out to several industry leaders that work in data science, AI, and related disciplines. And what they told us is that they look for employees, they look for smart people who have strong foundational knowledge in these areas here on the slide, and who are willing to acquire the necessary domain knowledge. Now, we all understand that there's no degree that will prepare you for addressing any type of domain knowledge. There are just too many areas in which we can apply data science and related disciplines. So having a comprehensive understanding of all possible domains is just unreasonable. That is something that you learn from the job. But what a good program is supposed to give you, what a good data science program is supposed to give you, is the foundational skills such as statistics, probability, algorithms, machine learning. This is what these companies are looking for. This is what they explicitly told us, and this is what our program is based on. So can we move on to the next slide? Thank you. So let me briefly talk about a few typical data science tasks. So without getting too much into specifics, because there will be some talks of application from my colleagues, but I would like to briefly discuss a few tasks that I typically associated with data science, which are data analysis, modeling, and prototyping. So the idea of data analysis is that is anything that includes extracting knowledge, for instance, about user actions to improve a particular business, as in the example of Netflix example a few minutes ago, right? If I give you raw data from which you can process and transform into actual knowledge about user behavior, then you can use that to improve a particular business. But that's not it. You can, when we talk about modeling, what we're usually referring to is the ability to predict, for instance, future demand for a particular product, right? Does it make sense to start building a new thing? Does it make sense to invest millions of dollars on a new show? Does it make sense to move my headquarters from one place to the other? So to drive decisions that have big consequences and large costs associated to them. And I'm sure this is something that Amazon recently did when they decided to locate themselves here, not too far from where we are here in New York. And not only that, but many areas of engineering require advanced visualization tool, and they require people who can understand them. So this is another area in which data science is really prominent. Can we go to the next one? Thank you. So just very briefly here, I don't think I have to convince anyone that given the skills that I just discussed, there are not that many people that can actually fill these jobs. Companies are really looking for people with the right set of skills that can fill this job. These jobs are really in high demand. And I mean, you can look at many different models here. We have one on the slide, but any model that you look at, although might change slightly in terms of specific prediction, they all agree that there is a huge gap between the supply of professional with these skills and what companies really need right now. So this is an area in which we really have way more demand than what universities can produce and other types of preparation can produce. And this is true again for computer science in general, but it's very, very true for big data in particular. Next slide, please. Now, if you can click one more time. Thank you. So now this is just to give you a sense of what we're talking about here. I mean, this gap between supply and demand really justifies and explains very competitive salaries, even for computer science jobs. So if you have these skills, if you have this foundational knowledge, it is not hard to find a position that it pays well. It's a fulfilling job. You do something that you prepared for and probably you like. And it really allows you to choose where you want to be and what you want to do within this area. And if you go to the next slide, there is another, and if you click again, similar statements can be made for business, also business intelligence, which is related, and where salaries are also very competitive, and again, demand is really, really high. Okay, and with that.
Okay, thank you, Dr. Gasti. I would like to mention also that for the participants, please take advantage of the chat box feature that is available to you in this webinar to type in your questions, and in the question and answer section at the very end of the webinar, we would be happy to address those questions. So with that general introduction to data science and careers in data science, it would be good if you have just a quick glimpse of some exemplar applications within data science. So with that, first I invite Dr. Helen Gu, Professor of Computer Science, to talk about her area of research in healthcare related data science.
Hi, good morning. So yeah, talking about the application of the data science, it is very hard to think of the more worthwhile use of the big data than saving lives. I believe you agree with me. Around the world, the healthcare industry actually is finding more ways to do that every day. Look at this picture. So it just shows some examples of data science in healthcare. You can see that's just listed some. By using the data science in healthcare can actually improve monitoring. Also, let's say the drug interaction detection or standardized image recognition, etc. Actually, there's more application. This figure just shows some of them. Please go to the next page. Yeah, according to the report from McKinsey Company, basically in the healthcare industry, there are four major kind of the source of the data. The first is activity data and cost data. So this kind of data actually, it's basic figures that show the amount of the care which has been supplied by providers, like let's say doctors, hospital in the system, and also the cost of the patient paying for that care. To do the analysis of this data actually can tell us about some spread of the certain diseases, also to identify the priority that should be given to dealing with the specific health threats. Also, by using this data, we can, using machine learning to identify any, let's say, duplicate examination and any waste of the cost. Second type of data is clinical data. So clinical data actually include the patient medical record and also the image they gathered during the examination or procedure, as well as the doctor notes. So by, let's say, the example of the using this kind of data, actually, for example, to do the analysis for patient record, can identify the people who are at risk of a certain disease, for example, heart disease or other cancer disease. Third type of data is the pharmaceutical R&D data, such as the drug information data and the clinical trial data. So this data actually can lead to some new discovery, the drug, and to cure the cancer or other specific diseases. So the last source of data is the patient behavior and the sentimental data. This data actually from the over-the-counter drug sales, like you go the pharmacist to buy the drugs. Also, these days everybody wears some the device, the phone or the watch that monitor your activity and heart rates. And also the data includes the patient experience and customer satisfactory survey data. So all this data actually to help us to monitor our lifestyle and also prevent the health problems. Please go to the next page. So all this data science in healthcare industry actually to advanced a lot of things. They're reducing the fraud, waste, and abuse, again, by the data we collected in the activity and cost data. We can try and efficiently prevent the fraud usage, like submit, let's say, the claim duplicated or they use the certain exam multiple times. Also, the predictive analytic to improve the outcomes, to help the patient, the outcomes, and let's say to improve the hospital, the efficiency, etc. And like third, I already mentioned, the wearables device that can monitor and prevent healthcare. And the last, it's the advance in pharmaceutical research. I think that's a major thing for application in the healthcare industry.
Thank you, Dr. Gu, for introduction of that area. And as you see, we picked actually three areas that are very diverse in terms of their focus. Next, I would like to invite Dr. Frank Lee, who is the chair of the Department of Computer Science in our Long Island campus, to talk about big data.
Good afternoon. Welcome to NYIT, the Big Data web theory. Within the 3 minutes, try to describe in this big field, which is really not possible. But I try my best to give you a general overview for the application area. As Dr. Polagasti mentioned, the big data field, actually involving many computer scientists involved over there, but mainly go from traditional big database point of view or from AI point of view. So today's lecture, we'd like to go from AI, which is machine learning, a point of view to look at that. But traditional database, they try to expanding the current database area, and they try to augment the power of the traditional database system, something like MongoDB, other fourth generation or fifth generation the language to handle those big data. Okay, so from big data, from AI point of view, we involving a lot of machine learning and data mining too over there. So basically, in data mining, you have to analyzing and also understanding or extracting those useful information from that, and then based on that information, you can predict the future plan. Okay, you can give it the future plan planning process. The next slide, please. Okay, so the first one I would like to talk about is a Classifier, which is a traditional data mining process. Okay, data mining process. Basically, we based on the past data. Okay, the more the better. You know, we extracting the knowledge from that, and then we building the statistical model. You know, those model we call the supervised learning model. Well, actually, there's a couple models. One is unsupervised. The other one is a supervised model. Supervised model basically means based on the data given, we verify the result. Okay, so go through the process, and you have a basic model we call statistical model, and then we review the result. Okay, to see the correctness or not, and then based on that, we have a basic model, and then we input the test data to verify you know, the correctness of the system. And then once the model reaches to a certain level, it's ready to accept the raw data. So that when the raw data come in, we use this classify to verify the result, and also helping the human, or helping the expertise to solve the problem. And this type of a model has been used very often, particularly in medical field, because a medical field, you know, needed that to do the decision support system. So that's the first area. And next slide, please. Well, another model also used very often. If you Google, well, if you shopping on Amazon or some other place, you can see that every time when you're shopping this, and they will give you a suggestion list and tell you most of the customers, when they buy this product, they're also interested in the following product. How they come out with this? This basically is based on a strategy we call the frequent pattern mining strategy. Basically, we review the past data. Like I said, the more the better, you know, and then figure out the pattern. Okay, figure out the pattern. And so sometimes they call the association rule. So basically, find out the pattern, which pattern go with, which item go with the other item, and then they try their best to finding the high frequency, you know, combination together. And of course, you know, go through the iteration process. Eventually, you will find a lot of pattern or a lot of items, they go together. And this has been used very often in supermarket, you know, strategic plan. For example, when you buy this item, and if you you know, interested in some item, they will give you the put out the coupon for you, or they will email you some incentive, you know, point to you. So it encourage you to buy another item, etc., etc. Or even in the supermarket layout, they will try to lay out those products together. So when you shop in this item, most likely you will also go into the next aisle and to buy the item. So you don't need to travel and from this end to the other end in the supermarket to get in the item. So basically, this gives you a lot of advantage to promote your business plan. So this we call the frequent pattern mining. That's one of the area. So next, please. So as I mentioned, the way to find this one is using iteration process, and you know, the first one size 1, size 2, etc., etc. So basically, eventually, you will find, you know, the largest set, and then they'll try to plan based on that. Okay, I think, you know, just basically try my best to give you, you know, the brief introductions for the big data application.
Great, thank you, Dr. Lee. And the third and the last of the sample applications that we would like to share with you is sentiment analysis and opinion mining, which will be presented by Dr. Hui Cao. Dr. Cao? Do we have Dr. Cao online?
Hey, just a whole second. We check whether what's going on. I cannot join from my computer today, so I just.
Okay. So why don't we move?
Choice here. Who is here now?
Okay, great, great.
Yeah.
Hi, sorry about that. Maybe you guys couldn't hear me. It's on my computer. Okay. Today I would like to talk about one of the very interesting applications for data science, which is sentiment analysis and opinion mining. So we all know that people actually, we are now living in the world of information overwhelming, and the user actually share lots of personalized information and opinions in social media. So for example, we may post tweets to talk about some opinions to some specific events. We may write some reviews to some products, or we may write some comments for some specific restaurants, and we may participate in some forum discussions to talk about our opinions to some specific events. One of the major problems is how we can actually retrieve the useful information from large number of data we have. Okay, actually, sentiment analysis and opinion mining is one of the key techniques for social media mining. So what's the sentiment analysis and opinion mining? So generally speaking, sentiment analysis is we try to determine what is the attitudes of a speakers, of writers, or the users to a specific events, products, or a documents. Next slide, please.
Oops, sorry.
So why we need sentiment analysis? So here's, I actually give you some typical applications for the sentiment analysis. So for example, if there's a new movie just released, and we want to know what's the reviews of this movie is positive or negative. And then, based on that, we can use that information to predict what will be the box office revenues for this new movie. Another example is we may want to know how do people think about the new products. So, for example, for the new iPhone X. Okay, so we want to know what people think the good things about the new iPhone X and what people think about the bad things about the new iPhone X. And then based on that, we can use it to rank the products, and we can also use it to predict the sales and even generate some personalized recommendations. So you may all aware that. So in many of the online shopping vendors, so for example, Amazon's, they actually provide their personalized recommendation functions, which is actually use the sentiment analysis on the reviews the user gives to other products. And another example is we may want to know what do people think about some specific political candidates, issues, or the government policies. And then based on that, we can even do the predictions for the elections outcomes. And there were also some many other applications for the sentiment analysis and opinion mining. So basically, it's one of the techniques which is widely used in data science. I think I finished.
Okay, thank you, Dr. Cao. So hopefully in the brief 3 introductions you heard, you got a sense of the very exciting areas within data science that are being investigated here at NYIT. And with that, I would like to spend a few minutes to introduce you to the highlights of the curriculum. Let me just move this. Okay. So the Masters in Data Science program is consists of 10 courses, a total of 30 credits, and it is offered in with 2 different tracks or options. One is the thesis option, and one is the non-thesis option. So remember, with both options, it is a total of 10 courses or 30 credits. So what you see right now is the non-thesis option. The non-thesis option is composed of 6 required courses and 4 electives. So a total of 10 courses or 3 credits per course is 30 credits. So a suggested semester map of the courses to be taken and this is a guideline, not necessarily a required sort of sequence. Many students take only 3 courses per semester, which is the 9 credits minimum required to be a full-time student in graduate studies, is programming to data science, topics in optimization, which really deals with the mathematical optimization topics, probability and stochastic processes. Hopefully you're already aware that you need a very strong background in statistics and probability in data science. And of course, introduction to big data. As you heard from Dr. Lee and Dr. Gusti, it is a important foundation for data science. And also you heard machine learning, the ability to build models that the computers can predict the outcome based on some raw data is a required knowledge base in the data science. Then you see that there are a number of electives here that will be chosen based on the advisement of your department chairs and advisors. And finally, there is one last required course, and that is a culminating capstone experience for the master's program. And it is a requirement by the New York State Education Department, and that's the data science project course. In this course, you will undertake an independent project under the mentorship of a faculty advisor, and that would be not only a validation of your knowledge base that you've gained in the master's program, but also a significant demonstration to your future employers as your capabilities in deploying a project in data science. So the thesis track or the thesis option differs very slightly from the non-thesis option in the sense that the project course is no longer there. And instead of that, you will be taking a 2-semester sequence of MS Thesis 1. You see that data science 880, 890, and 891. Thesis 1 and 2. Because now the one single project course is replaced by 2 thesis courses, you have obviously one less elective available to you. So that is really the only difference between the two in terms of the course count, 2 thesis courses, and as a result of that, 3 electives. Philosophically, students that opt for the thesis track or option are more inclined to doing research. A lot of them plan on continuing to a PhD program, even though that's not necessarily always the case. But for the students who want to finish their program and immediately seek employment in the industry, they would pick the non-thesis option. Just be aware that the thesis option is treated as a privileged option in the College of Engineering. So we look at the students' performance once they have finished the first semester before they can be before they opt in for the thesis option. So with that said, a number of adjunct or related peripheral issues you have to be aware of. If you have taken related courses, graduate courses within an accredited college or university within the United States, up to 6 of those credits, so 2 courses, can be transferred towards meeting the degree requirements for our master's in data science. Again, you can read in the text as long as they are not already used as part of degree requirements for some other degree. There is, again, a technical concept to be aware of. You need to be matriculated, and this is true of any university in North America. You need to be a matriculated student to take advantage of the transfer credits. If you're just taking 1 course or 2 courses here as a hobby or as a continuing education endeavor, this will not apply. Now, very important to everyone is given that the rigor and the depth that we delve into in delivering the educational experience in the Master's in Data Science program, a bachelor's degree in computer science or mathematics is appropriate background to enter the master's program. However, for students who may not meet all of the background requirements that are typical in a bachelor's program, we have listed this comprehensive list on the slide. These courses are the required undergraduate courses that we expect the students to have completed before they are taking their master's courses. Now, you have to be very careful. For some students, with for example, typical master's degree from North America, you may already have all of these courses, which means that all of your prerequisite courses are met. You may have missed a few or have not gotten good grades in a couple, so you have to take a couple. And if you had your bachelor's degree, then that's a very extreme case. Nonetheless, we accommodate it. If you had your bachelor's degree in a completely non-technical area, still by completing these undergraduate courses, you would be able to pursue your MSDS program here at NYIT. The term waivable means that all of these courses have a designated graduate course number, which means that if you're entitled to graduate financial aid, you would will meet the requirements of taking graduate courses. However, be very very important to be aware of this, that none of these courses count towards the 30 credit degree requirements for your MS Data. These are the background prerequisite courses, okay? And the grades that you get in these courses also do not contribute to your cumulative grade point average in your master's program. So again, the best way to identify what courses or that you have to take as part of these prerequisite courses is to, once you file your application, to be in touch with our evaluators to see, based on your transcript, what is or not needed to be taken. So in terms of the admissions requirements, as you saw sort of implicitly in the previous slide, a bachelor's in computer science, mathematics, or related field is the appropriate undergraduate degree, and depending on the degree you've gotten, those prerequisite waivable courses will be identified. Your undergraduate grade point average should be greater than or greater than 2.85, and for students who are international, a GRE, a graduate record examination, is required, and for your English language proficiency, a TOEFL or IELTS is also required. So with that, I just want to emphasize that since the program is at this point officially deployed, we are actively admitting students for our spring semester starting January. So I encourage you that after this webinar, and hopefully with having all of your questions answered, please apply to the MS program. Our staff and admissions office are very capable and very efficient in processing your applications and giving you a timely response in terms of your admissions decisions. And before I open it up to questions section here, I would like to also thank our Office of Graduate Admissions, Ms. Michelle Wachman, who is the Director of Graduate Admissions, and her team that have facilitated this webinar. So with that, let's see what questions we can answer in here. So,
and Hi, I'm Michelle Backman. I'm the Director of Graduate Admissions, and I'll read off some of the questions that you have been asking, and we'll let Dean Beheshti respond to those. So one of the questions was about the schedule for the program. You had showed a 3-semester schedule. What about people who are working or people who may have to go part-time? Is that an option?
Excellent question. And there was a point that one of our colleagues had pointed out, and I very efficiently forgot about mentioning it. So thank you for that question. So we do tailor all of our graduate programs to not only your traditional full-time students, but also working professionals. So a number of our courses are always offered in the evening. Okay, and if a course is offered in the evening one semester, the following semester it's typically scheduled during the day. So not only day students, traditional students can take advantage of completing the program, but also working individuals. So if you're deciding to take 1 or 2 courses per semester as you're working full-time and complete your degree in a number of years, that is perfectly doable. Many our students take advantage of this flexible scheduling with our other master's programs as well.
Someone asked about the campuses that this program is offered on.
Good question also. So we are offering this program both in our New York City campus and in our Long Island campus. The New York City campus is located on Columbus Circle, 59th Street area and Broadway. And our Long Island campus is in Old Westbury, which is northern Nassau County. The approach to all of our graduate programs within College of Engineering is that we have equally capable faculty in both campuses. The curriculum, the textbooks, the approach to the courses are identical or very similar. So students have complete freedom to float between the 2 campuses based on their own personal convenience. Ultimately, they get a NYIT degree. It nowhere in your degree or transcript indicates which of the 2 campuses you attended.
Sure. A couple of students asked about backgrounds. So if a student did not come from an engineering or computer science background, would that be okay? And how much of a math background do they need specifically?
Sure. So going back to the slide that I had put up before. So as you notice, if you had a typical, let's say, computer science undergraduate degree, most of the courses that are listed here would have been part of your undergraduate program. If a couple were not, for whatever reason, you will take them in your first couple of semesters to catch up, along with some of the graduate courses you would be taking. But let's look at a very extreme case, and I'm not picking on any particular major, but let's pretend that your undergraduate degree was in psychology. Okay, so most likely, and you would not be taking any programming or data structures or anything in your psychology degree. So, and I'm not, again, familiar with the math requirements and college degree, so let's just keep picking on that degree. So that means what? That means that you would need to take a course equivalent to Calculus 1, Calculus 2, and linear algebra to meet the minimum math skills required for this master's program.
Okay, someone asked about jobs that are available to students when they graduate.
Okay, so I think at this point I would urge you, rather than sort of listening to us, go to the, for example, U.S. Bureau of Labor Statistics, or Google jobs for data science degrees. I will only point out a couple of broad pieces of information for you. If you notice, a lot of universities in North America, in the US and Canada, are introducing bachelor's and master's degrees in data science. This is in direct response to the market demand. Otherwise, it wouldn't make sense for such an effort in very quickly deploying these new programs. If you look at the job market, every single industry, you saw 3 examples in the webinar today. from hospitality to healthcare to entertainment and so on and so forth, there is a need for analysis of data. So you could go into the operations team within an organization and look at the customer related data behavior. So data analysts, data scientists, data operations. These are the typical jobs that you would see. Financial sector, absolutely a big hire of graduates of these types of programs. So as nebulous as my answer sounds to you, it is actually true. Almost every sector in the business world nowadays is looking desperately for qualified data science graduates.
Two other questions that are sort of linked. One, someone was asking, they're seeing a lot of masters, as you mentioned, but with similar names: data analytics, data science, business analytics. What's the difference between all of those? And what's the benefit of getting a master's degree if someone is already working in the field?
Okay, so two questions, and they're both excellent questions. First one, again, yes, as you've noticed, some universities are offering master's programs that are more business school oriented, applications of data science, using software packages and tools that are readily available to really analyze, and visualize data that is being processed through these tools and software packages. And the emphasis in those programs is more at the end user sort of point of view. We have consciously decided to take a different approach. The data science program, as you see developed here at NYIT, is a far more analytical, deep approach to the fundamentals of data science. So, for example, you notice the course in statistics or optimization, they are not application-oriented. They look at the very fundamental mathematics involved in setting up algorithms, machine learning algorithms, or otherwise to analyze data. So even though you will be using tools, up-to-date tools within the course of your studies here at NYIT, you are not tied to a tool that may become obsolete in 6 months or a year. You would be learning the fundamental concepts, and then tied to your project and your thesis, you will have enough in-depth analysis to be productive and sort of continue your own continuous learning in this area as obviously the field evolves beyond your master's degree. So that was a conscious decision to make it more fundamental, more analytical than sort of a business-oriented end-user focus. The second question was to the working individual. So again, as you saw in an earlier slide, either it will give you the tools to advance in your current profession more significantly, simply by adding the tool set of being a data science capable professional in your current job, or for many individuals, it's an opportunity to now take a detour, maybe a very small detour or a very substantial detour in your career, now focusing on this very new, exciting area. Even though none of us have a crystal ball to predict the future, I would anticipate that very strongly that data science is not a fad that will go away in a year or two. It has become essentially a need that is now technically and analytically feasible. The need has always been around, and now we have the tools and the technology to come up with solutions to this long-lasting need, and I anticipate that the career path will just continue to grow.
Great, thank you. And the last couple of questions were about admissions and application housekeeping. The program is officially starting this spring, so we are accepting US students and US permanent residents as applicants for the January start of this program. international students, we welcome you to apply starting for the fall semester, which would be in September. This is just regular processing. We need to wait to get approval from the US government to issue student visas for the program. So if you are interested in starting for the spring and you're an international student, you can email us and we'll see if there's something that we can work out for you. In general, though, I would say if you're international, look towards our fall start term. Both applications are available on our website now. I did put application information in the chat box. So if you take a look there, you'll see a link to our application. You'll see an application fee waiver code that you can use if you are interested in applying, as well as the email address for the Office of Graduate Admissions. Overall, our tuition for this program is going to be about, let's say about $1,300 per credit. And you can multiply that by the number of credits for the program plus any additional prerequisites or waivable classes you may need. Scholarships are available based on your undergrad GPA, and you would find out about scholarships when you apply. There's nothing additional that you would need to do for those. If you're interested in assistantships or working on campus, that's something that we can discuss if you are admitted, and we would see what available options there are either in your department or elsewhere on campus. We are coming towards the end of the session, so if you have any last questions, please do drop them into the Q&A or into the chat session.
And with that, I would also add, thank you, Michelle, that if there are any other questions that will come to your mind afterwards, please feel free to contact us. So you do see the contact information for the department chairs in our both campuses. Interchangeably, you may not have even decided which campus you would like to, but Dr. Lee, F. Lee at NYIT.edu is the chair of the program here in Long Island campus, and Dr. Yoshi Saito, who is not on this webinar with us, Y. Saito at NYIT.edu is the chair in the New York City campus. And in case, I didn't mention it, I did not, so that you're aware of it, myself, Michelle, and Dr. Lee are joining this webinar from our Long Island campus, whereas Drs. Gasti, Gu, and the Cow joined from our New York City campus. I made this point to show you how seamless the operation between the two campuses are with respect to this program. So I don't see any additional questions. I thank everyone for having spent the time and your interest in NYIT. Our apologies for having gone 10 minutes over, but we look forward to seeing each and every one of you enrolled and starting with our data science program, either starting January or starting September of 2019. Thank you, everyone.